Okay, I guess we'll get started. I assume you can hear me. Bonjour, bienvenue à notre présentation sur le Ceph Manager. Hello, welcome to our presentation about the Ceph Manager. I won't subject you to any more of my French. Nobody wants that. My name is Brad Hubbard from Red Hat. I'll be taking you through the first part of this talk, and then I'll be handing over to my colleague here, Prashant Dhange from IBM, who will take you through the last part. The Ceph Manager, or the Manager, or MGR for short, is a crucial component of a Ceph cluster, responsible for overseeing real-time cluster operations and providing advanced administrative capabilities. This versatile daemon extends the functionality of Ceph monitors and OSDs, enabling complex management tasks such as performance optimization, data distribution, and failover management. Its modular design, incorporating components like the DaemonServer, base module, and various manager modules, ensures flexibility and adaptability to diverse cluster requirements. The Manager was contributed to Ceph by John Spray and others around the Infinalis dual timeframe, somewhere around that period. Today's talk will cover these topics. Why have a manager at all? What purpose does it serve? A rundown of the manager architecture, the process of module loading, how the manager transitions between standby and active when a failure occurs, how the Python global interpreter lock is used. Lastly, Prashant will give a detailed view of the op tracker and a look at future enhancements. So why the manager? The idea was to take the load off the primary monitor. The manager was designed to take load off the monitor and aggregate PG stats, perf counters, etc., and to lessen potential performance degradation and interference in execution of the monitors. It provides a framework for customization through a module interface. It was conceived as a diskless, stateless, independent service consisting of a C++ core with Python modules for ease of implementation and customization by a wide audience and allowing integration of many and diverse functionalities into the cluster. Okay, so this slide is showing the architecture. So down the bottom you can see a user sending a command to the manager that gets routed to handle command, and then depending on what command is being sent, the functions of that of the module API there will interact with the relevant component of the manager core itself. So you have the mons, the OSDs, and the MDSs contributing configuration and cluster state and perf counters to the manager. They're encapsulated in a cluster state class within the manager or a daemon state class or the config cache. You then have the core of the manager, the DaemonServer. So this is an active manager because only active managers are running a DaemonServer instance. Then you have the core modules displayed there, such as a base manager module, finding it difficult to read that. It's easy to read here. base pi crush. So these encapsulate like the OSD map, an incremental OSD map update, and a standby module. And then over here you have the actual modules themselves, the pieces of Python code that are being loaded into the manager. All right. Okay, so if we move on to module loading, Ceph manager.cc's small main function, Ceph manager.cc being the main file for the executable, for the Ceph manager executable. Its small main function creates an instance of the manager standby class, or a standby manager, and then calls its init function, which does some setup and configuration work, including calling PyModule registry init. That function then reads manager module path to find the modules directory in the local file system, and then calls PyModule registry probe modules to try to load all those modules present which are not listed in the manager disabled modules list. So basically it walks the directory path in the file system looking for module code. So if it finds a directory in there that represents a module, such as a dashboard module or the crash module, it'll descend into it and try to load the code for that module. Okay. For each module, a PyModule C++ object is instantiated and the relevant Python class is instantiated, and then PyModule load is called, which takes Python's global interpreter lock. More on that subject later. And creates a Python sub-interpreter for the module, and then attempts to load the class that inherits from manager module. So in other words, a sub-module. And that's usually the main, well, I think always the main class for each individual module. This loads and runs the code of the actual module itself. A check is then done for a manager standby module subclass, and if one is found, a version of the module that runs in standby mode is loaded. This allows to essentially have two modes for the module, a standby mode and an active mode. But this is only currently implemented by a couple of modules, Dashboard and Prometheus, from what I could work out. We then run a canRun method on the module to verify that it is ready to run. So the transition from standby to active. Firstly, on the monitor, if there is no active manager or an active manager has failed, or if we are failing over using the manager fail command, so intentionally failing over the monitor, we call a function called promote standby. And that function selects the first standby and promotes it to active by updating and publishing a map, a manager map, that tells the relevant manager to activate itself. On the manager, sorry, all managers start up in standby by creating an instance of the manager standby class. In this class, they do little other than send a beacon to the monitor each time we periodically run our tick function, which is quite common in Ceph daemons. Most of them will have well, I think all of them have a tick function, which in the case of the manager defaults to run every 2 seconds, and it allows you to periodically do some work. But like I said, in the case of a standby, it's not doing much other than sending a beacon to the monitor to let the monitor know that we're alive. In manager standby handle _ manager _ map function, we check if the latest manager map lists us as active. If so, we create a new instance of the manager class, which is the main manager class, MGR class, which instantiates a DaemonServer object. The DaemonServer object does the bulk of the heavy lifting and the ongoing work when it runs its tick function. It does so via the send report and adjust PG's functions. Send report populates and sends an mmon manager report, including PG stats, health metrics, etc. The adjust PG's function adjusts PG num and PGP num and sends commands to the monitor to update them with the newly calculated values. If we were active, in other words, if we, as the manager receiving the map, were active at the time and are no longer marked as active in the map, we respawn the Ceph manager executable by using an exec VE command, which replaces the existing executable with a new version. So everything is handled by modifying the state in the manager map and republishing it. Once the manager consumes the new map, it understands what its state should be and makes the required adjustment. The GIL. In Ceph, we have a GIL class that's large G, lowercase I, lowercase l. It's used in any scope in which you need to hold Python's global interpreter lock to work with Python objects and/or call Python C API functions. These should not be nested, as a second GIL acquire will deadlock. It uses resource acquisition is instantiation to manage the GIL. The class constructor acquires the GIL lock and sets the current thread state. The class destructor releases the GIL and resets the thread state to null. So we create a class instance when you need to acquire the GIL, and when the instance goes out of scope, the GIL is released. The GIL has had its issues in terms of performance, and ways around this were discussed in yesterday's DevConf meeting. And they included changes to Python which have recently become available involving Python sub-interpreters that don't rely on the GIL, and their ability to relieve GIL contention, as well as moving some of the modules to be equally distributed. One of the other things discussed was moving some of the modules to be equally distributed across all running managers, manager instances, to reduce the chances of performance issues on a manager that has many busy modules loaded. So in other words, we're thinking about, instead of having an active manager and two standbys where only the active manager is running modules, we would then distribute some of those modules to the standby managers so that the load is equally distributed. As an example there of a GIL deadlock, that tracker at the bottom, it was a classic deadlock issue where one thread has the GIL and is waiting for the standby module state lock in this case, and the other thread has the standby Pi module state lock and is waiting for the GIL. So they're both waiting for the other thread, and neither can make progress. The ways to detect that sort of thing in a manager, just quickly, is if you run something that periodically dumps the stacks for those threads, it'll become clear after looking at a few of them that those threads are not making any progress. Similarly, you can get a core dump from the manager and then through a process of inspecting those threads and also doing some code inspection, it becomes clear what's going on in terms of grabbing locks and not letting them go. So I encourage you to take a look at the Ceph Manager module developer's guide in the docs. And at this point, I'll hand over to Prashant.
Yeah, thanks, Brad.
Thank you.
That's right.
Thanks.
Yeah. Yeah. Bonjour, everyone. Okay, that's the only word I know. Okay, so here I will be briefing you on the Ceph Manager Op Tracker. It's basically like why we need it and how it's going to help in the troubleshooting. You want to come this side? Yeah, thanks. Yeah. So basically, like without MGR op tracking, like investigating a problem, like what's really problem with the MGR, was really like time consuming. Like if you take an example, like what really happening inside the MGR module, for that we need to collect the debug logs and everything, and that's really time consuming because for the customers who's experiencing that issue, we have to request and then collect the logs and then analyze it. So some of the half of the code work like runs on the C++, half of the in the Python. So we really know where the exact problem, whether it's in the module or it's actually in the core MGR daemon. So this feature, I would say, like will really aid in investigating and diagnosing the issue, and it really saves the time. Just like so, I would say like the op latency. Like if you run some MGR command, it will give you where the most of the time is being spent by that particular command, whether it's within the module, like when the op is being handled by the particular module, or it's within the core, like where, because when you run the command, it first goes to the messenger layer, then it at the manager level, the manager reads that command, and then actually it hand it over to the module if it's being handled by the module, and it's being handled by the core MGR, then it's being handled at the core level. So it's really efficient to troubleshoot any slowdown or hangs, even the simple issues. I would quote one of the recent issues we encountered where if you fail over one of the like if you do the MGR fail, like to fail over to the another standby MGR, and if you initiate like the command, like any Ceph crash command or volumes command, like Cephfs commands, we used to get a E not supported error. That's because that particular module where you are actually initiating that command was it not loaded by the active manager. So that really gave us kind of like using the op tracking mechanism to find where the exact problem is, whether the module is it not accepted or rather like trying to execute that op, or it's the core it's having the problem. So even like if you consider an example, like if you are running some Cephfs commands or even the Cephfs dump or status or any other module command, you can really trace out the performance, I would say. Like if you consider the Ceph PG dump, so you can figure it out like where the most of the time is being spent. So right now it's just a basic kind of gives the information at what level it came and then finish the op. But we are yet to implement some more advanced kind of like implementation where you can track that particular module at the like in the handle command or other, I would say, or in any other the MGR commands like the report, where it maintains the daemon metadata and everything. So using the op tracker, also you can trace the specific commands which particular module is being handled by, like which op is being handled by which module. So I'll go to the next slide. Yeah, so key metrics here would be like this, as I said, like the op latency. You can really find out the op latency, like where the most of the time is being spent by that particular op. So the op backlog is something like you can figure it out, like what are the recent ops being performed by the MGR, and with the queue depth, which are currently in being handled, or rather like which are in the queue. Which MGR is yet to execute those ops. It's similar to like what we have it in the OST for the mons. We have the same set of commands which we need to execute through the admin socket or within the self-tell command to dump these ops, rather like which is being handled by the MGR. So dump ops in flight, it gives you the currently ops which are in flight or yet to be executed. The historic slow ops, something like that particular op has taken more than 30 seconds, like what we have it as a default time, which will flag that particular op is a slow op. So all the slow ops will be kind of like which has taken more than 30 seconds will be shown in the historic slow ops. So the dump historic ops is similar, like it's a recent ops which is handled by the MGR. The others are like just by the duration, like historic ops by duration. Blocked one, which are rather like that MGR op is still like taking more time and still blocked and not progressing. So you can at least see where it is actually landed based on at what state it is in. So dump block op count, it just gives the number of blocked op at the moment on the MGR. Okay, so this is the op like life cycle, how it goes to the different state. So initiated and header read are the same, like when the managers, the messenger layer at the manager started reading the message, or rather like containing that command. Throttled is the state where the manager is allocated the memory space to read the whole message into the memory. All read is something like the messenger layer has finished reading the op, and it's ready for give to the manager to execute. A dispatch is the time the messenger gave it to the manager, and started is when the manager accepted it and the operation is being now executed. Queued for module is something the op is handled by the particular module and not by the core module. So for the core module, only after dispatch and started, it just lands to the done, because the core module is just kind of heavily depends on the, not heavily I would say, but mostly the depends on the modules, individual modules, like where we have initiated the commands, like Ceph fs commands or any crash command, like crash module commands. So queued for module is something like it gives you the queue for module, and the next state is something like which module is going to handle that command. Basically, like whatever, like if it's a Ceph volume related MGR module, then you'll see the Ceph fs related calls are going to that particular state. Then is like off has been completed. So this is one of the example which I just got it from the one of my test cluster. I'm not sure if you're able to see the font properly. So this is for the Ceph fs volume creation. If you have seen, like it took like 3 seconds to finish that one. So if you see, like it just started and then queued for module, it went to the volumes module and it's done. So although it's saying it spent most of the time, just saying, at the module level, though it's like just printed the done, but it actually spent more time on the volumes. But I think I got the wrong output here. But yeah. Yeah, from the future advancement perspective, I think Neha already mentioned in the today's keynotes. So we are like theoretically we are thinking like where the bottleneck will be if you think about the scalability from the Ceph perspective. So monitor and the OSDs are good, but we think like there could be possibly like we going to hit some issues for the MGR from the scalability perspective. So if you think of like the MGR actually collects the PG stats from all the OSDs every 5 seconds, and it aggregates that one to maintain the PG stats, like or rather like when you initiate the PG dump command, or when you see the Ceph status for the individual PG stats is what you see the currently being seen by the MGR, I would say. And if you consider an example, if you have the 10,000 OSDs and collecting that PG stats from 10,000, more than 10,000 OSDs, and that single daemon is going to handle that one, that could be a problem to rather like aggregate and also collect the stats and to maintain that PG stats rather like say showing on the Ceph status. Apart from that, if you think like so only one active MGR is running, and the standby MGRs are kind of like standby. They don't do any kind of work. So we can think of like handing over some of the active MGR work to the standbys, which are less important from that perspective. Apart from that, like in the op tracker, currently we don't track the op at the module level, where we can see, okay, what really the individual module API is doing, or rather like where, what kind of operations it's rather like requesting the stat, or rather like maps from or operating on the particular maps, OSD maps or MGR map, you can say it. So we don't know what really happening at the module level. So we are thinking of adding the tracking mechanism at the module level using the Python decorators. Apart from that, there are like open tracing APIs. We are still kind of like thinking on that one, like how can we achieve that, like the tracking the op at the module level. Apart from that, like so we are also thinking of having one additional module to maintain the audit logs, to see to kind of like to keep information for when we run the offline tools, like Rados offline tools like Ceph Object Store tool or Blue Store tool. Those are the offline tools, and when you run that one, so you those commands actually are offline, so they just print logs on the terminal, but Ceph cluster doesn't have any information like what really we have done with those, like for the particular OSD, or if you think of like Ceph FS recovery tools, so they manipulate the metadata pool if you've done some like doing some recovery, journal recovery, or any sort of like advanced recovery, Ceph FS. So we're thinking of having some like audit module which can keep track of like those offline module can log some basic information when what kind of command they executed and what really what kind of like modification it has done at the Rados level or the Ceph FS pool level, you can say. Apart from that, the potentially we can keep this clustered information. Like we don't basically like when we see the customer problems, right? We always request like so they give us like basic information like we hit this issue, but they don't know like what really happened in the past, or rather like when they started observing this issue. So having this information of like when that cluster is created and when it got upgraded over the period of time, so that could be helpful for us as well to keep track of what really happened with that cluster over the period of time. So that crucial information will be really useful in the future as well for us to how that cluster over the period of time got handled, or rather like upgrade, and if there are any sort of bugs or issues that cluster hit, so that at least we know like when we interact with a particular customer, so for that particular cluster we can think of where we can use that information, at least for the troubleshooting or future enforcement perspective. I think that's all from us. Take a question. Thank you.
Any questions?
Yeah. Good.
Mark?
Hey, I was curious if you guys ever looked at rewriting the manager in Go
Have we?
Go.
or another language that might
Yeah.
less skill issues.
Yeah, I think we mentioned Go yesterday. That was mentioned at the DevConf, but I think they also mentioned Rust, but I think both of them got shot down for different reasons. But whatever works, I guess. You know?
Yeah, I
Like,
think we should take
consider
that
anything.
to the CDM. Yeah. Yeah.
Sadly, I missed the Dev Summit yesterday. I'm not sure if this is a question that has been solved or if it's not a problem for most of you. But on Debian and on the manager, we have this problem with some modules in the are loading a Python library that in turn is loading some Rust code using Py03, and that library is not compatible with sub-interpreters. Is that something that is thought about when you are creating the infrastructure, or is it still a problem?
I think probably Neha can answer that one. So, but yeah.
Sorry, you're loading a module into the manager.
The problem is that the multiple modules are loading the code for verifying SSLs and logging in and so on. And I rewrote some of the login code to remove that library, but the other ones that verify SSL certificates are using the OpenSSL library that is in turn using the crypto library that in turn is using the Py03 library, which is loading some Rust code. And that chain is not supported in the sub-interpreter. So it crashes. So the first time it loads, it's fine. The second time, it crashes. So
Is there a tracker for this?
yeah, that's the issue.
Okay,
Yeah.
I can't.
Yeah, no, it's a dashboard, the REST API, and I think also there was one more module that was crashing. Depending on which was started first, that was one loaded and the other ones were crashing. Yeah. And in the beginning, I think it was in the util module, so all of them crashed. And then we moved the codes to the different modules, and now only a few of them.
Is this a problem specific to your environment, or because obviously there must be modules running in other environments that are crashing, but
Yeah, I'm not sure because a lot of people that are running Debian and also Proxmox have reported the same issue.
okay.
I'm not sure how widespread the problem is, if it's because a lot of people are using the manager, of course, and haven't.
Yeah.
Yeah.
Is there third party module? Like, no. Okay.
The main included module. So it's the REST API, the dashboard, and one module more.
Okay.
Okay.
Yeah.
Wasn't aware of it.
Hi, good.
You mentioned it was conceived as a diskless, stateless daemon. Is that still the advice? Is it a good idea to run the manager as a diskless, stateless daemon?
Well, I guess what we're trying to say there is it's not persisting data, so it doesn't require a lot of disk space. So
Yeah.
yeah, if it's persisting data, it's sending it back to the monitor to do so. Okay.
Yeah.
What are you doing to make the performance better for large clusters? I know you had a bullet point there to make it work for 10,000 plus. What's kind of the path of the change?
So we are actually basically like we are still at the initial phase, like we are discussing various possibilities where it can break from the scalability perspective. One thing is like probably 5-minute interval is too aggressive to collect the stats from all the OSTs, where we can tune it, but there are different aspects we are thinking around that one, like how can we make that is scalable, like because having like collecting stats from 10,000 OSDs and then aggregating, and that's just single daemon is doing that all the work. So we are bringing that to the CDM, right? Yeah. 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 Yeah.
Yeah. Yeah. Plus, there have been a couple of recent PRs merged, such as giving each module its own finisher thread, and also allowing always-on modules to be disabled, which makes these things easier to track down. Yeah, but we discussed a lot of options yesterday for improving performance, so now we've got to sort of zero in on the ones we want to try and implement.
At least at the module level as well, autoscaler, balancer. So we need to think like, basically I think the performance numbers will tell us, but having that large cluster is not like not possible at the moment, but we are going theoretically, like what's there in the code and how we can improve from the scalability perspective.
We'd probably better wrap this
Yeah.
up. If anyone wants to grab us, grab us.